All right, this is the notes for section 5.2, trigonometric functions, page 2. So we're dealing with page 2 here. All right, so let's look at example 3. Find the 6 trigonometric function values, or ratio values, if you will, of an angle theta in standard position if the terminal side of theta is defined by, and then so defined by this linear equation where, of course, x is less than 0. So let's graph this line, essentially. So let's do this. I'm going to do it over here so I have my room to write my answers for my trig ratios. We have negative 2y equals negative 3x. Move the 3x to the other side. And then divide by negative 2. So y equals 3 halves x. And again, for x values less than 0. So this would be, starting at the origin. And we would go up 3 over 2. But again, we only want negative x values. So we're going to go down 3 over 2. So, somewhere here, let's say. Think about the ratio that is the slope and its rise over run, or change in y over change in x. So we're starting at the origin. So when we draw in our little right triangle, always again to the x-axis, we can think of this side as 2 and this side as 3. The rise over the run. However, both of those are negative because we went to the left and we went down. Both of those are negative. The ratio of them, of course, is positive. All right, so we need to think about our r. So remember, r is equal to the square root of x squared, which is 4, plus 3 squared, which is 9. So r is equal to the square root of 13. All right, and so that's our r. And so let's find all of our trig, the values of all of our trig ratios, our trig functions. So we want to do sine theta. Now theta, what's theta? Theta is this value here, right? In standard position, so that's theta. Starts on the x-axis, goes all the way over. I'm sorry, it's a little tight there. My drawing's a little small. It goes all the way over to that terminal side of the angle. Okay, now what's interesting is if we draw the angle in standard position, then the sine, cosine, tangent of that angle excuse me, will be the same as, let me redraw it so that it's a little bit bigger, the same as that angle there. Okay, so the sine ratio, cosine, tangent ratio, secant, cotangent ratios of that angle theta will be the same as the angle coming all the way around. Okay, so, and it works because we drew that triangle to the x-axis. If we drew this angle over here, then we're talking about like that angle in there, and that's not related to it. Okay, so you have to draw them, the side of the triangle, it has to go from our point down to the x-axis, or up to the x-axis, I guess in this case, up to the x-axis, always. Never draw it over to the y-axis. All right, so sine of theta. So sine of theta, that's this angle out here. Again, it's the same as the theta in here. All right. All right, so let's go on. So sine of theta, that's going to be y over r. So negative 3 over the square root of 13. Of course, that's going to be multiplied top and bottom by square root of 13. So that's going to be negative 3 square root of 13 over 13. Okay. Write small because there's not a whole lot of space here. So cosine of theta. All right, that's going to be the x over the r. So negative 2 over the square root of 13. But of course, I'm going to multiply top and bottom by square root of 13. So negative 2 square root of 13 over 13. All right, and then finally, tangent of theta. That's going to be the y over the r, so 3/2. The negatives, of course, cancel. All right, and then let's do the reciprocals. Cosecant of theta. Now, I wouldn't take this one and flip it. I would take this one and flip it, right? We want to flip it. The square root's now going to be upstairs. If I did this, I wouldn't want to flip it because then now this radical's downstairs again, and we have to simplify that, and it just gets more complicated. So this we will flip, and so that's a negative square root of 13 over 3, and there's nothing to simplify there. So, it's best to kind of write this one because you're just going to use it. You're not going to use the simplified version when you go to flip the reciprocal. All right, secant theta. Negative square root of 13 over 2. And finally, cotangent theta, and that's 2/3. Now notice, we're in the third quadrant. We know all students take calculus. T, the tangent should be positive. It is. The other two are negative. The reciprocals follow suit. Okay. All right, now, the next example is talking about something called quadrantal angles. These are angles that that terminal side fall on an x or y axis. Okay. To find the trigonometric function values of a quadrantal angle, that is, angles with terminal sides on either the x or y axis, you may use the coordinates of any point on the terminal side, but we often use a point that is 1 unit away from the origin or on something we call the unit circle. Remember I said in the previous page that we call this distance to our point r because we'll sometimes think of it as a point on the circle. And that would make up the radius. And so this is a perfect example. And we call this the unit circle because the radius is exactly 1. All right, so again, I can use any point I want. So I could put a point way up here. But why use a point of, say, 0, 3 when I can use a point of 0, 1? On the last page, again, we talked about how any point on that terminal side can be used to create your ratio. So why not use the simplest numbers? And the simplest numbers on these quadrantal angles is 0, 1, negative 1, 0, 0, negative 1, or 1, 0. Okay? Now, what's great about this is you can't use, well, maybe not what's great about it, but on the last page, when I said you had to memorize instead of SOHCAHTOA, opposite hypotenuse, adjacent hypotenuse, opposite over adjacent, those absolutely, you could use them somewhat in here if you think about this being our angle that we're interested in, because the sine, cosine, tangent of that angle is the same as the angle here. We could use opposite adjacent hypotenuse. But you must use x, y's, and r's when you're dealing with quadrantal angles, because there is no, you can't draw a triangle in those cases. So let's try an example. Find the 6 trigonometric functions for each angle. So 360 degrees. So that means we have rotated through 360 degrees. So what's it look like? It looks like that's the initial side. That's also the terminal side. So a point on there, let's call it the point here. We call it the point 1, 0. I cannot draw a right triangle. Okay. Think about, what it would be like. So I had draw a right triangle, and I bring this point further down, and it's here. The triangle would collapse, right? The hypotenuse, like this is the hypotenuse, but now as this point comes down, the hypotenuse and the x are the same thing because the y is 0. All right, so here, y is 0, x is 1. So let's write these out. We have x equals 1, y equals 0, r equals 1 because we're on the unit circle. All right, so once we have those things, now we can write the ratios. So sine of theta, sine of 360, if you will. Let's go ahead and write 360. Sine of 360 degrees, well, Sine is y over r, so that's 0 over r, 0 over 1, or just 0. Now this is really small space in here, so cosine of 360 degrees, sorry, that's really tight in there, 360 degrees. Again, cosine is x over r, so that would be 1 over 1, or just 1. And then tangent of 360, all right, so that's going to be y over y over x, and so that's a 0 over 1, or 0. All right, now the reciprocal functions. Cosecant of 360 degrees, so that cosecant is going to be r over y, so that's going to be r is 1 over y is 0, and this is undefined. All right, secant of 360 degrees, that's going to be now r over x, so that's 1 over 1, which is just 1, or the reciprocal of 1. And cotangent of 360 degrees, remember the cotangent, that's going to be x over y, so that's going to be 1 over 0, which again is undefined. So the reciprocal of 0 is undefined, right? 0, undefined. So in this case, 2 of them are undefined because both of those have x's on the bottom. And y is on the bottom. And the y in this case is 0. So what you want to do is, create like a unit circle essentially and plot your point for that particular angle, and then think about what the x, y, and r are, and then use the rules that we learned last page, dealing with x, y's, and r's. You cannot use SOHCAHTOA for quadrantal angles. You could kind of cheat and use them for other ones, but not for these. All right, next one, B. An angle theta with terminal side that passes through the point 0, -5. So where is that? That's down here. So you can think of this one as 0, -5, but wouldn't it be easier to just, again, think about the unit circle? Let's take it up here. And so, it's the same terminal side, so we're going to think of it as 0, -1. And so what is x? X is 0. Y is -1. What is r? R is +1, always positive. Now, if you use this point, that's fine. X is 0, r is -5. X is 0, y is -5, and then r would be +5. But again, you're going to have to reduce all those, so it's just easier to use the unit circle. So x is 0, y is -1, r is +1. All right, so let's say sine, and let's just call it theta this time. We could say theta, or, we know that's 270 degrees, so if you want to say sine of 270, that's fine. So sine of theta, that is, again, y over r, so that is -1 over 1, which is -1. Cosine of theta, that's x over r, so that's going to be 0 over 1, or 0. Tangent of theta is y over x, so that's -1 over 0, or undefined. All right, cosecant theta, that's just the reciprocal, -1. It's r over y, so -1. Secant of theta, that's going to be undefined, because remember, cosecant, sine is x over r, so now we got r over x, x being 0, so it's undefined. In this case, cotangent of theta, instead of, can't really think about, well, what's the reciprocal of undefined? It's going to be 0, but think about cotangent, that's x over y, so 0 over -1, or just 0. All right, for the next 6, pause this video and try to find what the tangent of each of those are, and then pause the video and see how you did. All right, tangent of 540. So we got to think about a coterminal, right? So we could subtract 360 degrees. If it's over 360, we want to get a coterminal angle that's smaller. Best if the angle is between 0 and 360. So we're going to subtract 360 from that. So 540 minus 360, and that's 180. So really it's the same as the tangent of 180 degrees. And so we know we're 180 degrees. That's over here. So really what we're doing is we're going around several times, right? We're going 1.5 times around to get to our angle. But that will be the same as just doing tangent of 180. So that's a coterminal side. That's a quadrantal angle. And so think about that point. That is -1, 0. So we get x equals -1, y equals 0, r equals 1. And so the tangent, that's y over x. So that's 0 over -1, or just 0. All right. Sine of 90 degrees. So that's going to be up here, right? Again, we can't draw a right triangle with quadrantal angles. All we could do is pick the point and say, okay, that's a 0, 1. The r value is 1. Sine, what I often do is I say, so I don't have to keep everything in my head at once, sine, well, that's y over r. And that's something you got to memorize, y over r. And so now I can just go over here and pick my things out. That's equal to 1 over 1, or just 1. All right, cosecant of 270. So 270, that's 270 degrees is here. Pick a point. That point is 0, -1 with an r value of 1. Cosecant is r over y. And so just pull off your r and your y. So that's 1 over -1, or -1. All right, -360. Remember, negative means we go in the opposite direction. So that's one of these things here, -360 degrees. Pick a point. Of course, we will always put it on the unit circle when it's a quadrantal angle. So we have a 1, 0, and an r value of 1. Cotangent, that's x over y. Again, you got to memorize that. So now I just pull the values off. For x over y, that's 1 over 0. That's undefined. Just a note too, don't ever leave your answer as 1 over 0. That doesn't make any sense. 1 over 0 tells me that you don't know it's undefined. So don't leave it like that. Make sure that you say it's undefined. All right, secant of -90. All right, that's down here. Again, pick a point. That point is 0, -1 with an r value of 1. Secant, remember secant is the reciprocal of cosine. That's r over x. And so now we just pull our r and our x. So that's going to be 1 over the x, which is 0. This one also undefined. All right, cosine of 0, well, that's just this. And so that'll be 1, 0 with an r value of 1. Cosine, remember that's x over r. And so x, that's 1 over 1, which is 1. Okay. All right. Also, so just before we start the next part, we're going to see this more and more as we go on through our discussions of trigonometry, is we will often want to take a sine of a theta, a sine of an angle, and we'll want to square it. And so we're lazy, mathematicians are lazy. We don't want to have to take the whole ratio and square it. I had to put it in parentheses. So a shortcut, instead of writing in parentheses sine of a theta quantity squared, we'll just say sine squared theta. It means the same thing. So if I write sine squared theta, again, we're not squaring the angle, we're squaring the ratio. So we would take the y over the r, and we would square that ratio is what we're doing here, okay? But instead of using those parentheses, we'll just do sine squared theta. It's the same thing, okay? All right, identify the quadrant for each angle. All right, so they give us some information. We got to figure out what quadrant it's in. So tangent of the angle is positive. Okay, so thinking back to this stuff that we were doing before, right? Go look at the last page. The tangent of an angle is greater than 0. That means the tangent is positive. Where is the tangent positive? The tangent is positive in quadrant 1 and quadrant 3. So we know from this information we are in quadrant 1 or we are in quadrant 3. All right, let's look at the secant. The secant is less than 0. So the secant is negative. Remember that the secant and the cosine are the same result. So where is the cosine negative? The cosine is negative in quadrant 2 or in quadrant 3. So both of these things have to happen at the same time. So clearly we are in quadrant 3. Okay, you get how we're doing that? This kind of narrows it down some. This one narrows it down some more. Where are both of these true? Which quadrant has both of these is what we're looking for. So the sign is negative. Sign is negative. Where is the sign negative? The sign is negative in the third and fourth quadrants. So this is either in quadrant 3 or quadrant 4. And cosecant, well, that doesn't really help us. The cosecant and the sine are the same thing. So we can't narrow this one down. This one is in quadrant 3 or quadrant 4 because we use the same, essentially the same ratio, right? They're reciprocals of each other. So that doesn't help us narrow it down. The best we can do is 3 or 4. All right, so where the sine is negative is also where the cosecant is negative. So, all right, can't do anything with that one. All right, the next one. Sine is positive. So where is the sine positive? That's quadrant 1 and quadrant 2. Where's the cotangent negative? Cotangent's negative in the quadrant 2 and quadrant 4. So where's the overlap? Quadrant 2. Okay. All right, so that's going to help us when we get to this example 7 then. Find the domain and the range for each function. Oh, actually, no, this will help us in the next, this stuff that we just did is going to help us more on page 3, I think. Let me look at page 3. Yeah, it's going to help us on the examples in page 3. Okay, so find the domain and range for each function. So theta, what restrictions do we have with the theta that we can put in for sine? All right, so think about it. There's no limit to what we can put in for sine and for the angle into sine. So the domain is going to be all real numbers. Now the range. So how big can this get? Now you probably notice some values up here, and this will be actually an easier question to answer if we were playing around with our calculators a little bit more. But remember what the sine is. The sine is y over r. So the bigger the y is, the bigger the sine will be, right? But as the y, I mean, how big can y be? All right, so if we think about a rotating, let's say we're on the unit circle, and as we move around, how big can y be? The biggest point for y is up here. And so what would be the ratio at that point? Y is the biggest. What is the ratio of y and r? So r will so that for that point we have 0, 1 with an r value of 1. So the ratio will be 1, right? And that's the biggest it can get. If we move the point over a little bit further, the r is starting to come back down. The y is starting to come back down. The r is 1, right? The r is constant for this circle. But as this point moves further, the angle moves further on, the y coordinate's going back down. All right, and so how low can it get? So if you think about the extreme would be here, right? We have 0, -1, and an r value of 1. So this ratio is smallest when this point is down here. Again, that would be -1 over 1 or -1. So as this goes around, your y value is getting, as it goes past this point, the y value, magnitude y, is getting smaller again. And so that ratio is getting closer and closer to 0 until it gets to this point here. And then the sign of these angles is 0 because your y is 0 at these 2 points. So this thing, as the angle rotates around, the ratio, the r is the same, but y is getting bigger and then x smaller. And the biggest that y gets is 1, and the smallest it gets is -1. So this will be more obvious when we go to do some graphing of trig functions in a later section. But the range is from, I got to do inclusive here. It fluctuates between -1 is the smallest value that sine can be, up to +1 is the biggest value. All right, the cosine is similar, but its max and mins occur at different spots. So the cosine, remember, that's x over r. It's biggest here and smallest here, and it's 0 at these 2 spots. So it's similar to this, except the max and mins occur at different angles, but the domain, again, is all real numbers. The max values and the minimum values are the same as we saw for sine, but they're not occurring at the same locations for the same angles. But they do have a max and a min at 1, because at this point, again, we have 1, 0 with an r value of 1, so the ratio is 1. If I take that angle and move it this way or that way, the x value is getting a little smaller, and so that ratio would be smaller, somewhere between -1 and 1 always. Now the tangent, that one's a little bit trickier. If we think about that, remember that's y over x. And there are certain values, certain angles that would be undefined. So if we think about the domain, I can't put any values, any angle in here. Certain angles will create a tangent that's undefined. And we saw those up above. When is this ratio undefined? When x is 0. So that would be here and here. X is 0, right? So we can't put a theta value of 90 or 270 or any multiple thereof, right? So we'll write it like this. We'll say that the domain is theta such that theta cannot equal, well, we could say 90 degrees, but it's 90 degrees. It's any... Let's see, let me think about tangent. It's 90 degrees or it's 270 degrees. Let's stop there for now and just think about it being in one full rotation. So those can't be either of those because it would make it undefined. But the range, and again, this will be more clear when we go to graph some of these things. The range is -infinity to infinity. Because you think about it, x can be down close to 0, in which case if x is 0, then this thing is 0. But if x is big, right, and if y is big and x is getting close to 0, then this thing could explode and get really big, right? So as even though the you might think of this as being, oh, it can't be bigger than 1, but as this gets close to 0, this thing is going to be really, really big. Or as x gets big and this gets 0, I mean, it could be reverse negative. Again, don't worry too much about this stuff. We'll expand this to more, a bigger domain. We just did one full revolution, but eventually we'll talk about multiples of these as well. So, think about coterminal angles. We could just add 360 and just keep going, add 360 again and again. We can find a lot more than just these two, but in the range of 0 to 360, it can't be 90 and it can't be 270. Again, also, it can't be any of those coterminal angles with those same terminal side.